All right, if your warm-up is done, go ahead and close it. We'll just use your notebook for now. If your warm-up's not done, please get it done quickly. That should only take us like 3 or 4 minutes after class starts to get all finished up. All right, so what we're looking at today, factor and factor pairs. Okay, definitely something you've heard of before. All right, may not have used those actual words. All right, a lot of times in elementary school, sometimes they'll introduce things, but maybe not give you the fancy word that goes with it. But I can almost guarantee you've discussed factors and factor pairs before. May not have just been called specifically that. So, a factor is a number that you multiply by another number to get a given number. Okay, and we'll do plenty of examples of this, but a factor is basically those numbers that you multiply to get another number. All right, so your second question, really the first question you had to type things for on your warm-up, was asking you for things you can multiply to get the number 45. Okay, there are actually 6 factors for the number 45. What is something we can multiply to get 45? What are 2 numbers? We should all know at least one set because it's the same number for every number into infinity. There's always one that we should know. Ayana? And? Close? 5 and what? John?
5 and 8.
Close? Super close? Mason?
5 and 9.
5 and 9. Okay? So those are 2 factors of 45, 5 and 9. Now, here's one thing you need to remember. 5 times 9 is the same as 9 times 5. Okay? Order doesn't matter when you multiply. So 5 times 9 is the same as 9 times 5. What else can we multiply to get 45? You guys are missing the easiest one. Jordan? And? No. 1 times what? Yeah. 1 and 45. 1 is a factor for every number. It's 1 times whatever the number is. So 1 and 45, 4 and 9. What else? This is one that's not so obvious, but I talked quite a bit about this divisibility rule yesterday. Mason?
3
Yes.
and 17.
Close. I believe it's going to be 3 and not 17. How did you know it was 3? Because that's the important part. How did you know it was 3? Mason, do you know how you knew? Or just took a good guess? Not sure? Anyone know? 3 times what gives us 45? And I'm going to talk about how he could have known that in a second. Mateo? 15. Yep, 3 and 15. So 1 and 45, 4 and 9, or 5 and 9, and 3 and 15. Those are all factors. They're things that we can multiply to get a given number. Now, if we look at the word factor pair, okay, I just want to talk about pair. P-A-I-R, not P-E-A-R. If you think about a pair of socks, a pair of gloves, a pair of shoes, how many gloves, socks, and shoes are you getting in a pair? 2. So when we look at factor pairs, we are looking at the factor of numbers, but in pairs. So they are 2 numbers that you multiply to get another number. Okay? Factors are just all the numbers you can multiply. A factor pair is each individual set. 1 and 45, 9 and 5, 3 and 15. Those are pairs because there's 2 of them. That's the difference between those 2 words. Questions about that? If you understand factor and you understand what a pair is, you'll know what a factor pair is. Okay? So, we're going to look at some examples of factors and factor pairs. All right. So if I want to look at the number 15. Oh, hold on. Trying not to write the same notes 4 times every day. All right, so the number 15. What can we multiply factor pairs to get 15? What's one set? Ayana?
5 and 3.
5 and 3. Same thing as 3 and 5. Okay, so if you wrote 3 and 5, that's the same exact pair. Remember, we're using a dot, not a multiplication sign. Jordan, what else? 1 and 15. Okay, anything else? All right, then when you're listing the actual factors, all right, now I'm going to show you the way I do it so that way I know I've got all of my factors. I will list my smallest and my largest separated from each other. Here is why. As I move in, I will know if I've got all the numbers. So my next pair was 3 and 5. Well, the only number between 3 and 5 is 4, and 4 will not go into 15, so I know I have all of my factors and factor pairs. Okay, Jordan, John, do you have this written down? Yes or no? You have that example written down? That's impressive because I didn't see your pencil touch the paper. You have to write this down. You need to teach me that skill. 18. Okay. What is a pair that we can multiply together to get 18? Everyone should have their hand in the air for the first one because it's the easiest that you can come up with. Mason, you were up first, so you can pick the easiest one or you can pick a different one. 9 and 2, which is the same as 2 and 9. What else can we multiply to get 18? Leah?
18 and 1.
18 and 1 or 1 and 18. Doesn't matter which way you write it. Should be one more set, James.
6 times 3.
6 and 3 or 3 and 6. Doesn't matter. Then, to make sure I got them all, if you do your list and separate the smallest from the largest, you'll know if you have them all. So our smallest would be 1 and 18. Then we had 2 and 9. Then we had 3 and 6. Well, the only number between 3 and 6 is 5, and 5 doesn't go into 18, so I know I have all my factors. That's why I like to write them by separating the smallest from the biggest and coming to the middle together. Then I know if I have them all. Okay? If it's easier for you to list the factors first, you can list factors first. I think it's easier to do the pairs first. Okay? So, I want you to take a few seconds and come up with the factors and factor pairs for 27. And then we'll talk about those. You can put your hands down and relax for just a second. We'll give everyone else a moment to think. All right, one pair of factors for 27. Leah?
1 and 27.
1 and 27. Smart girl, get the easy one first. Jordan,
9 and 3.
3 and 9, 9 and 3. Okay, same difference. Anything else? Okay, so we can kind of check ourselves to see if we're right. So we had 1 and 27. Then we had 3 and 9. Well, in between 3, there's 4, which doesn't go into 27. There's 5, which doesn't go into 27. 6, 7, and 8. None of those go into 27, so our list is done. Questions on finding factor pairs or factors? Okay, then the last one you're going to do is 54. So whichever list is easier first, your factor pairs or your factors. But come up with both lists. All right, someone give me a factor pair for 54. The same people every time. Justin, 9 times 6. Another one. John. Perfect. I got you. 1 and 54. Everyone should always know that one. Every single one of you should be able to raise your hand to give me a factor pair at the beginning, because 1 goes into everything. Anything else? There is one more. Actually, there's 2 more sets. Leah, what's one?
11 and 4.
That would give us 44. On the right track. Jordan? 27 and 2. It's an even number, so we should know 27 goes into it. We need one more, I believe. Mason seems a little more confident than Mateo. What do you think, Mason?
7 and 8.
56. We're super close. But I hope you guys always remember my saying, I'd rather you think and be wrong than sit and not think. Jordan? 3, yes. How did you know it was something with 3? Because I'm glad we're recognizing that. All right. Hey, that works. Let me explain why we should know it was divisible by 3. Just as we should have known all of these were divisible by 3. Okay, and I mentioned this several times yesterday. If you could learn these, what's called divisibility rules, it's going to make your math life so much easier. So I'm going to say this several times between now and June. If you look at all 3 of these original numbers, 15, 18, 27, 59, or 54. What is 5 plus 1? What is 8 plus 1? What is 2 plus 7? What is 5 plus 4? So we have 6, 9, 9, and 9. All of them are divisible by 3 because when you add these digits up, 6, 9, 9, and 9, the sum of these digits, sum is adding, is divisible by 3. Therefore, the number is divisible by 3. Okay? I could have a really large number. Okay? Now I'm just pulling this out of nowhere, so it may not be divisible by 3, but I can sure find out. If I had the number 1,530, 3. Okay? If I wanted to know if that was divisible by 3, all I have to do is add these numbers. What is 1 plus 5 plus 0 plus 3? That is 9. Therefore, 1,503 I know is divisible by 3. Do I know how many times? No, not right off the top of my head, but I can figure it out. You can tell if a number is divisible by 3 by adding the digits and seeing if the sum is divisible by 3. So all of these, we should have known 3 would have been one of our factors. Then you just have to figure out what the matching pair is. Okay? So then our list of factors for 54 would have been 1 and 54. Then we jump to 2 and 27. Then we had 3 and 18. And we had 6 and 9. Okay, the only thing between 6 and 9 is 7. 7 doesn't go into it. And 8, which does not go into it. So that is all of my factors. Factors and factor pairs go right together. All right. Factors are all the numbers you can multiply to get that number. Factor pairs are the sets of numbers that you're actually multiplying. Okay. So your ticket out my door today is all of this, including the examples. We're not going to sit in here and not write down what we're supposed to. So today when you leave, this is what you will show me in your notebook. And then once you get to where you're going next, you can put it in your folder or your backpack or your locker. But this is what you will show me as we leave. Any questions about what a factor and a factor pair is? Okay. And you may have to do some small division to figure out what the factors are of something. But we all know how to divide it, and they're not real big numbers. Okay. So what you are working on today is 2 more IXL assignments. E4 is just factors. Read the question carefully because it may just ask for one factor. So like if they wanted one factor of 15, you could use 1, 3, 5, or 15. But if they're asking for one, they only want one. If you listed all 4 of those in the box, they'd mark it wrong because they asked for one. If they ask for all of them, you would need all of them. Read the question carefully. E5 is factor pairs. So that's where you're figuring out what 2 numbers can you multiply together to get the given number. Okay? So we're working on E4 and E5. Several of you, when I graded yesterday's assignment, E3 and E6, you didn't do it. So you need to do 4 and 5 first. If you get E3 and E6 finished during class, you can bring it to me and show me, and I'll change the grade. I came back last night and had all late work. If you emailed me and I sent an email or a remind message to parents, if you emailed me in Canvas yesterday prior to 8 o'clock, everything was graded and put in Skyward. I am not taking any more emails. Your work needs to be done on time between now and tomorrow. So E4 and E5 need to be done first. Then if you didn't get it shouldn't be a 3. Yes, it should. E3 and E6 done yesterday, and you have time in class today to get it done after E4 and E5, you can just show me your computer and I will change it. But I am not reading through 30 some emails of kids that can't do their work on time. Do your work on time. Okay? So we're working on E4 and E5. You have more than enough time to get that finished before you walk out of here. There is absolutely no reason why E4 and E5 should not be done before you leave. Most kids were getting to 80% in an average of 5 to 7 minutes. You have 20-ish minutes left of class. If you're struggling, ask for help. Other than that, there's no reason not to be done with E4 and E5 before you walk out the door. And then I would check your 3 and 6 and see if you actually did it yesterday. If you didn't, and it gets done before the end of the class, you're going to show me your computer. You are not emailing me. I'm not checking Canvas emails again before the end of this grading period. Any questions? Leah, you'll have to show me in a minute. Did you fill out a pass? I'll get to it in a minute. Go ahead.